everyone. The table shows a linear relationship between the average height in feet of trees and the number of years since the trees were planted. And we have to find the rate of change, which is the slope. Now, what I noticed looking at this is we don't have a constant number here. This is 4, this is 5, this is 3, and this is 2. And similarly here, we don't have an average rate of change. So what I'm going to look at, you can do this in a calculator and use your linear regression. What I'm going to do is look at these two numbers because it's easier. And I notice if I can get, I have 1, 2, 3, and I have 10 and 24. If I get a midpoint and the fact that I know that it's linear, I can solve this problem without a calculator. So what I'm going to do is take the midpoint of my x's, so or these values here. So I'm just going to add these two numbers up and divide by 2, and that's 34 divided by 2, and that gives you 17. Now I can somewhat write my table of values, and what I did is I put the finding I had for 2, and I noticed that my finite difference is 7. So what I also did is I subtracted 7 to get my 0 at 3. And then I double checked and I made sure as I add 7 that it matched up to my 6. And I didn't bother with those two because I know it's linear. So I do see the pattern. So for our slope-intercept form, we do have y equals mx plus b, and our b happens to be 3. That's your y-intercept. So I can write this as y equals mx plus 3. And I can solve for the slope that way. So if I write y equals mx plus 3, and then use one of these points, I would actually use the smaller, don't use the larger one. So I'm going to use 1 and 10 and plug that in. My y is 10, I'm calling this y, this x. So 10 equals m times 1 plus 3. And then I have 10 equals 1 times m is just m plus 3. And if I subtract 3 from both sides of the equation, I get m equals 7. So your slope is 7 feet per year. And if you had to write the whole equation, that would be y equals 7x plus 3. And that's it. Thank you. Have a nice day. Bye-bye.